Hi, in this lecture we'll talk about the quantitative comparison type questions. From one of my earlier videos you would remember that one question type in the quantitative section of the GRE is the quantitative comparison question. I'll write it here for you. It's called quantitative comparison. As its name implies, you have to basically compare quantitative values. So let's see how to attempt this question. So this question format will present entries in two different columns labeled quantity A and quantity B. So you'd be given two values in two columns titled quantity A and quantity B. In each column there will be either a number or something that could take a numerical value, a variable or some word problem formulation. For example, the area of triangle QRS or the number of employees at safe zone. So you would have two columns, column A and column B, and you may have, let's say, two numbers such as 3 divided by 7 or 4 divided by 7, which you need to compare. Or you may have a variable or a word problem formulation such as given here, and you have to basically compare the value given in column A with respect to the value given in column B. So what are the options or the multiple choice questions or the options that are given to you? So our job is to compare these two quantities, that is A and B, trying to figure out which one is bigger. The four quantitative comparison answer choices are always the same. So you have these four options: option A, B, C and D. Option A means quantity A is greater. Option B means quantity B is greater. Option C means the two quantities are equal. Option D means the relationship cannot be determined from the information given. You should commit these choices to memory as soon as you can. So during the test, as I've already emphasized numerous times, time is very short. So you don't have the luxury to basically think about that what each and every option means. So it's better to basically memorize that what does or understand properly that what does each and every option mean. So let's see further, or let's try to improve our understanding of every option. So remember that A means that quantity A is always greater in every way in all cases. Similarly, B means that quantity B is always greater. It couldn't possibly be anything other than greater than quantity A. So if you choose A, let's say, if you think that the value, let's say X and Y, the value X is greater, so you should choose A if X is always greater for all the possible values that could be, could be added into or could be plugged into this variable. Similarly, if you choose value B, so you should choose it if Y is greater than X in all possible cases. So this is what A and B means. Choice C means that at all times, in all ways, for all possible values of a relevant variable, the two quantities are always equal. So once again, as before, choice C means that both the values in column A and column B are always equal. You can't say that in some cases they're equal and in some other cases they're not. No, then you can't choose C. So C means that in all given cases, quantity A is always equal to quantity B. This is what choice C means. Finally, choice D means that things don't always stay one way. As I just said, that there could, if there are certain cases, let's say, where the two quantities are equal and there are other cases, other values, when you plug it into these variables, so let's say A becomes greater than B or B becomes greater than A. So in that case, you have to basically choose option D. In other words, different values of the variables or different numbers within the specified ranges allow different choices that produce different results. So in that case, you have to choose option D. So let's attempt a basic quantitative comparison question. And remember, this is a very easy, very basic question. So I don't think that you can ever get such an easy or elementary question in the actual test. But here we're just trying to understand how to basically go about, or how to basically solve this question. So with every such question, down here, you would be provided with 4 options. All right. And you would have to basically choose one of them. So now your job is to compare column A with column B. Since these two values are numbers, so they are very easy to compare. So one way to basically compare fractions is to basically cross multiply the denominator with the numerator of the other side. So in this case, we can, to compare, we can basically move 7 over to the other side. Now 7 times 8 is 56, and under column B, this is column A and this is column B, and under column B we have 53. So clearly 56 is greater than 53. So now think about it. What should be our right option to choose? Yes, that should be option A, because A is always greater than B. Since these are numbers, these are not variables, so it's very clear that 56, no matter what happens, would always be greater than 53. Okay, that was an easy one. Let's move on. All right. This is another very basic question. So let's read it. ABDE is a rectangle. So A, B, D, and E is a rectangle. Now what are our two quantities, quantity A and quantity B, or column A and column B? So column A has the value of the area of triangle ACE. What is triangle ACE? This is triangle ACNE. So this is the triangle. So this is quantity A, and quantity B is half the area of the rectangle ABDE. So this whole rectangle's area divided by 2 is quantity B. Okay, so you might be thinking that we don't have any actual numbers for the sides of this triangle or this rectangle. So how would we basically find answer to it? Okay, let me first put these 4 options over here: A, B, C, and D, and we have to choose a single correct answer. All right. But remember, this is a quantitative comparison question. In quantitative comparison, you have to basically keep one thing in mind, that you have to compare the two values. It's not necessary to find, in this case, the actual area of the triangle or the actual area of the rectangle. If you clearly see in this diagram, no such information is provided. Similarly, under this prompt, no such information regarding the sides of the rectangle or the sides of the triangle or the height of the triangle, nothing is provided. So actually finding the area of the triangle or finding the area of the rectangle is impossible. However, it is possible to basically compare these two values. So let's see how to basically solve this question. So the quantity A is basically area of a triangle, and we know that the area of a triangle is half of the triangle's base multiplied by its height. Okay. Multiplied by its height. Okay. So that's column A. What about column B? Column B is half the area of rectangle ABDE. So how do we calculate the area of a rectangle? That's length times the height. So we have length times the height, but it says half the area, so we have to multiply this whole area of the rectangle by 1 over 2. All right. So they're pretty similar to each other. Now let's see what we can do. So we have under column A, we have half of base. So what could be the base of this triangle? Let's call it AE. So this AE is equal to B actually. So that's A and E. And what's the height? So this is basically the height of this triangle. We can draw a perpendicular from vertex C onto AE. So this would be the height. But remember, this height is basically equivalent to AB or ED, whatever you want to call it. So let's call it AB. So this is basically our area of the triangle. Under column B, we have half of the length. So what is the length of this rectangle? So these two sides are the lengths of the rectangle. AE or BD, we have a choice. We can either write AE or we can write BD, since we have AE on this side. So I'll also use AE over here because this would help us in cancelling these values out. Similarly, what's the height of this rectangle? So it's AB or DE, and for the same reason I'll choose AB because it's also present over here. And now you can clearly see that no matter what the particular size of each side is on this rectangle or on this triangle, these two values are always going to be equal to each other. So in this case, our right answer is basically answer C. All right. Okay, so let's do another question. N is not an odd integer. So this is a prompt given to you. Further, this is some additional information. The value of n is greater than 6, but it is less than 10. Alright, so there's another one important rule to GRE, that you should never ever assume anything. So here the question or the prompt says that n is not an odd integer. So what are odd integers? We know that if we have these integers 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on, let's say 10 and so on. So 1, 3, 5, 7 and 9, these are odd integers. So when the prompt says that n is not an odd integer, so one common mistake that people often make after reading such statements is that they assume that, okay, if n is not an odd integer, so yes, n is an even integer. And yes, n could be an even integer, but it's not just that n is definitely an even integer, because nowhere in the question it says that n is an integer. So the question does not explicitly state that n is an integer. If it had stated that n is an integer or a positive integer, then you could have said that, okay, if it's not an odd integer, then it must be an even integer. But the question has not stated anything of the sorts that n is an integer. It has just stated that n is not an odd integer. So it can't be 1, it can't be 3, it can't be 5, it can't be 7, it can't be 9, it can't be 11 and so on and so forth. It can be 2, it can be 4, it can be 6, can be 8, 10, 12, 14 and so forth. But it could also be, n could also be, let's say 0.1 or 3.5 or minus 17.7 or any other, positive or negative decimal number. So with this idea in our mind, let's think about what are the possible values for n. So we know that n is basically, remember this is not true, n is basically greater than 6 and n is less than 10. So what are the possible values of basically n? So it could be, could n be 7? No, because 7 is an odd integer. No. Could n be 8? Yes, because 8 is not an odd integer. Could n be 9? No, once again, we also established that 9 can't be equal to n. So is our answer 8? I mean, should we say that, okay, n is 8 and quantity b is also 8, so they're equal? No, because we also talked about it that n could also be any decimal number. Since n's value vary between 6 and 10, so n could have, infinite number of values. N could be 6.1. So let's plug 6.1 here. Is 6.1 greater than or less than quantity B? No, it is basically less than quantity B. Here you can see that if we plug 8, which is a valid value for the variable n, so quantity A and quantity B are basically equal to each other. But if we plug in another possible value for n, so then the relationship is basically turned, which means that we cannot determine that what's the relationship between quantity A and quantity B. So in that case, out of the 4 options that we have, A, B, and C, and D, option D is the correct option for this question. All right. We have one more quantitative comparison question. So a fair 6-sided die is rolled twice. All right. So we have this. Let me draw a dice. We have this dice, and it has 1 over here, and let's say 5 written here, and let's say 2 here. So this is a fair 6-sided die, and it's rolled twice. So what's quantity A? The probability of rolling 6 twice, or the value 1/6. So what's the probability of rolling 6 twice? So when I roll the dice once, what's the probability of rolling 6 once? Since there are 6 surfaces to the dice, so, and only the number 6 appears only once, so the probability of rolling 6 once is 1 divided by 6. So what if I roll the dice again, because the dice was rolled twice? So what's the probability that I roll 6 again? So what is the probability for the second dice? That's again 1 over 6. What would go between them? Since the relationship between, or the condition, is that of an AND. I mean, if you were to basically state the question differently, you would say, what is the probability that that when you roll the dice for the first time, it turns up as 6, and when you roll the dice for the second time, it again turns up as 6. So because we used the word AND in this statement, so the relationship between, or the operator between them, would be multiplication. We'll talk about probability and the word AND or and how to basically deal with them later in the videos where I basically cover probability. For now, this is how we basically compute probability for this basically statement. So the probability of rolling 6 twice is 1 multiplied by 6 for the first roll, and 1 divided by 6 for the second roll. You multiply them and you get 1 divided by 36. So that's your quantity A. What is your quantity B? It's 1 divided by 6. So clearly, since this value is smaller than 1 over 6, so our quantity B will always be greater. So it means that out of the 4 options that we have, our right option is quantity B. Alright. So approximations in quantitative comparison. Okay, let's do some approximations in quantitative comparisons. So the biggest quantitative comparison strategy idea is this: do not do calculations, do not do more calculations than necessary. So that's very important. And I think we have already seen a couple of questions where basically we didn't actually compute the numbers or the solutions for the given variables or the given expressions or the given equations. We just compared the value in column A versus column B, and we basically approximated, or we basically estimated that which value would always be greater or smaller or maybe equal to each other. Often we don't need to figure out the exact values of quantities A and B individually. We just need to determine which one is bigger. All right. So once again, let's do some geometry in quantitative comparison. So we have the circle with the diameter AB, and the length of the diameter is basically 4. Now what is quantity A? The circumference of the circle. And what is quantity B? That's 12. So how do we compute the circumference of the circle? So the circumference of the circle is equivalent to 2 pi times r, and r is basically the radius. Now remember that AB, since it's the diameter, I can write it as d diameter, or I can also write it as twice of r. So the diameter is basically twice of r, and we have 2 times r in our expression under A. So now what we can do is we can basically, for convenience, you can write 2r pi, or you can replace 2r with its value 4. So we get 4 pi over here. For B, under B we have the number 12, we can write it as it is. And now basically you have this value over here, which is 4 pi. Now normally you're given the value for pi, but it's always recommended that you memorize this common value. It's 3.1416. So what would you get if you multiply 4 by 3.1416, and you know this decimal number, it continues. So you might be tempted to basically multiply 3.1416 by 4 and then write it down here and be very confident about your answer when you compare these two values, but there's no need. If you think about it, if you just multiply 4 with 3, you get 12, right? And since this number is slightly bigger than 3, so definitely the value under A would be bigger than 12. So under A, you'll get a value which is bigger than 12. I'm putting this plus sign to basically show that this value is not 12, but something that is bigger than 12. We don't know what that exact value is, but it's at least bigger than 12. Under B, we have exactly 12. So which means that quantity A would always be greater than quantity B. So see, we did not basically compute the exact value of quantity A, but still we were able to successfully and confidently compute or compare these two values. Alright, let's move on. Okay, so we have these two values. So we have now you can see that we don't have any prompt over here, and you would often get these questions where you don't get any prompt, but you only get values for quantity A and quantity B. So let's compare them. So we have to basically find the 32.8% of 5,929 and 41.6% of 5,041. Once again, it's a very simple, straightforward question, and I don't expect that you would get such a question under actual GRE tests, but this is just to basically explain you certain concepts. So once again, you might get tempted when you see something like this, and you may basically reach for your calculator, but remember, you don't need a calculator for this question. There's an easier way to basically solve this question, and that is, if you think about it, 32.8% is very close to 33%, right? And although it's 33% is a slightly larger number, so let's put this plus sign with it, which shows that whatever number this is, it is basically instead of plus, I should put a minus over here, a minus. All right, so this minus number tells us that whatever number you basically compute here, it's going to be less than this number. All right, so what about this one? What is it closest to, since we are approximating? So this is closest to 6,000. All right, and once again, 6,000 is greater than this number, so we'll put a negative sign over here. Once again, these two negative signs, they're telling you that whatever number you compute here, whatever number you get here would actually be smaller than the value of quantity A. So the 33% could be basically rewritten as 1/3 approximately, right? And when you multiply 1/3, or you take 1/3 of 6,000, it is basically 2,000. You get 2,000. All right. I'll bring down this negative sign with me. Okay. Similarly, what's this value? This is 41.6 divided by 100. And instead of like this number, instead of going up, now we're coming down. So let's call it 40%. 40%, or I'll write as 40 divided by 100 multiplied by 5,041. Similarly, instead of going up, we're coming down, or we're reducing this number. This is 5,000. So you would understand that why I'm putting these plus signs with them. These plus signs show that whatever number you compute here, it's an underestimation. Like here we had an overestimation. So here we have an underestimation. So whatever number we compute here, it's going to be smaller than this number. So we have 40 divided by 100, so which is basically equivalent to 2/5. So what is 2/5 of 5,000? Think about it. What is 2/5 of 5,000? You can easily compute it. You can cancel out 5 with 1,000, and then you can multiply 2 with 1,000, and you get 2,000. And we have a plus over here. So what does this mean? It means that we have a number which is smaller than 2,000, and here we will have a number which is greater than 2,000. So definitely quantity B is greater than quantity A. And so from our 4 options, A, B, C and D, which option is correct? Option B, yes. Because option B would always be greater. And you can check it. I don't recommend checking it during the exam, but you can check with your calculator right now. This value would be slightly greater than 2,000. This value must be slightly smaller than 2,000. All right. So notice that if both columns contain numbers, just as these two values, there are no variables. These both are numbers. So notice that if both columns contain numbers, then there must be some definitive relationship between the two quantities. Meaning, by definitive relationship, it means that your option would either be A, B or C. You can't say that you cannot have D as a correct option when both the values are actually numbers. If let's say you have for column A and column B, you have some variables in them, X and Y. Now with these variables, there's a possibility that the answer might be D. But instead, if you basically had numbers, let's say 6 and 7, now it's absolutely impossible to have D as a possible answer. So whenever you get two numbers for column A and column B, you can straight away get rid of option D, and then you're only left with 3 options: option A, B and C. All right. So matching operations. So in any quantitative comparison, we are trying to determine the relationship between two quantities. We could say that between the two quantities, there is an unknown relationship. So this is a very powerful idea. Let's see how it works. It's important to recognize that there are mathematical steps we might take to simplify the problem that do not change this underlying relationship. So what are these mathematical operations that you could perform on both column A and column B? Let's see. You can add the same number to both quantities. So let's say you have option A, column A and column B. So and you have certain, let's say, values under them. So what you can do is that you can add the same number to the both quantities. So what this basically rule is saying is that there is some unknown relationship. There is an unknown relationship between these two values. It could be equal to, it could be greater than, it could be less than. And you don't know, right? So you have this ability to do certain operations between these two values. So you can add the same number to both the quantities. You can subtract the same number from both quantities, just as you could do with an inequality or an equality. And you can multiply or divide, be very careful, by the same positive number. It's very important. So you can add or subtract positive and negative numbers. So I can add 3 onto both sides. You know, the relationship, the actual relationship, whatever it is between these two values, it wouldn't change. Or I could basically subtract, let's say, I don't know, 9 from both of these values, and the relationship wouldn't flip, it wouldn't change. I could also basically multiply both the sides by, let's say, 3, and once again the relationship wouldn't change. This is you know, something that is allowed. Or I could basically divide both the quantities by the same number. However, I cannot basically divide by -3. This is basically not allowed, or any negative number. The same goes for multiplication. I cannot basically multiply x and y by a negative number. No, that is basically not allowed. So this is one very powerful idea that you need to be basically very careful about. All right. So once again, it's a very, very basic question, and I've talked about how to basically compare different fractions. So we have under column A we have 35 divided by 8. Under column B we have 13 divided by 3. Both are improper fractions. To compare fractions, you just need to basically cross multiply the denominators. So under A we'll get 35 multiplied by 3. Under B you'll get 13 multiplied by 8. And if you're confused that why, you know, this rule works, so think about it. Let's say we have 35 divided by 8 over here and 13 divided by 3 over here, and we can say that, okay, let's multiply both sides by 3, and we just saw that you can multiply both sides by a positive number. This is allowed. So the 2 3's would cancel each other out, and then you can say that let's multiply both sides by, let's say, 8. And since these two are again positive numbers, so it's possible, it's allowed. These two 8's would cancel each other out, and we'll be left with 35 multiplied by 3 and 13 multiplied by 8. So now it's pretty easy to basically, you know, compute these values. I would leave it to you to basically compute the values and find the right answer. All right, next question. So now we have variables. So for this question, the previous question, as I said earlier, that from all the 4 options A, B, C, and D, as soon as you see 2 numbers, you can straight away, you know, cancel option D, and be sure that the right answer would be either A, B, or C. All right. But in this question we have variables, and the variable is x. So which means that from the options A, B, C, and D, D is actually a possibility. So you cannot straight away get rid of this option. All right. So let's solve it. So we know that x is greater than 3. This is the prompt, or this is the information provided by the question. Under column A you have x plus 10, and in column B you have 3x plus 3. All right. Now once again think about it. what do we do when we, let's assume, just assume I'm going to put this operator or this sign in a box. All right, let's assume that there's an equal to sign between them. All right, so now what can you do with the left hand side and right hand side? So normally when we have the same variable on both the sides, we try to isolate the variable on one side. So what we do is basically that we move x to the right hand side. To do that, what we need to do is basically we need to subtract x from both the sides. So that would mean that 3x minus x plus 3. So the two x's would cancel each other out, and we'd be left with, when you subtract them, 2x plus 3. And to isolate x, you have to move 3 over to the other side. So 2x plus 3 minus 3, 10 minus 3, cancel them, and you'll be left with 2x and 7. Now it's much more easier to compare this simplified form. All right, to be clear, remember, you should never write any basically logical operator between column A and column B. This was just to explain this concept. All right, so now you have to basically compare these two values. So x is greater than 3. So think about it. Let's say, what if x were equal to greater than 3? What if x were equal to 4? So 2 times 4 would be 8, which is clearly greater than, let's separate them out, which is clearly greater than column A. So if x were equal to 4, so column B would be greater. But remember, nowhere in the question it says that x is an integer. So there's a possibility that x could be 3.1. Let's try that out. 2 multiplied by 3.1. That means that x is 6.2, which is actually less than 7. So if x were equal to 3.1, column A would be greater. Which means what? That our right option is option D. All right. One last final question. So let's quickly read it. Machine A can produce 11 nails in 14 seconds. So A can produce 11 nails in 14 seconds. Machine B can produce 7 nails in 9 seconds. All right. What is quantity A? Quantity A is the time machine, not time machine, the time machine A takes to produce 1 nail. So, and the time machine B takes to produce 1 nail. So you have to basically compute the time that machine A takes to produce 1 nail, and similarly the time machine B takes to produce 1 nail. All right. So that's easy. And if you think about it, how to basically solve it, let's change these values. Let's say if the question said that machine A basically produces 2 nails, all right, in 14 seconds. So how would you solve it if it were 2 nails in 14 seconds? So think about it. So you would take 14 and you would divide 14 by 2. So this is your time and this is basically your work. And it tells you, when you simplify it, you get 7 divided by 1. So it tells you that for each single nail, work here is basically producing the nail. So to produce 1 nail, machine A takes 7 seconds. So that means that you have to basically divide time by work. So here you have to basically divide 14, which is the time, by 11, and that's the time machine A takes to produce 1 nail. Remember, since nails are in the denominator, so whatever number you get after dividing 14 by 11, That's the time that machine A takes to produce 1 nail. Similarly, for B, you have 7 nails in 9 seconds. So you have to divide 9 by 7. Once again, you have 2 fractions. And to solve them, you have to basically cross multiply. So you'll get 14 multiplied by 7 on the left hand side under column A, and 9 multiplied by 11 on the right hand side. So what is 14 multiplied by 7? 7 times 4 is 28, 7 times 1 is 7, plus 2, 8, 9, that's 98. And 9 times 11 is 99. Very slight difference between the two, but definitely column B is greater than column A. So from the 4 provided options, the right option here is option B. So this is all about the quantitative comparison questions. I hope this lecture was helpful. Thank you for watching. Stay tuned for future videos.